Hello everybody, this is Mr. Combs, and we were supposed to meet through Blackboard Collaborate on Wednesday, but HCTC was closed, and I noticed from the news that Lee County and Wolfe County were also closed. So we didn't get to meet. I don't want us to get behind, so we have the greatest common factor and lowest common multiple. That was the information sheet we were going to go over on Wednesday. So if you want to pause this video and go ahead and pull that out or download it and print it off, I'm going to be referring to that throughout this video. You won't actually see that sheet on the screen, but I will work out some of the examples on the screen. So, two numbers that are of interest to mathematicians who study number theory are the greatest common factor and the lowest common multiple. So the greatest common factor is sometimes called the greatest common divisor, and it is the largest number that divides or is a factor of all the numbers in a group of numbers you're considering. Now we're going to consider groups of two numbers. So one way to find the greatest common factor is to list the factors of a number and then pick out the largest factor that is common to all of them. And this works fine for smaller numbers. So the first example that we have asks us to find the greatest common factor of 36 and 20. Uh-oh. So what we can do is we can list the factors of 36 and we can list the factors of 20 and then pick out the largest number that's in common to both lists. So when I list the factors of 36, I'm going to have to check all of the factors or all of the natural numbers that are less than the square root of 36. And if you remember, the square root of 36 is 6. So I'm going to check 1, 2, 3, 4, 5, and 6. I don't have to check more than that because when I check to see if those numbers will go into 36, when I create the factor pairs or whatever I have to multiply that number by to get 36, that will account for all of the factors that are above 6. So I know that 36, that 1 is a factor of 36, and I know that 1 times 36 is 36. 36 is even, so I know that 2 is a factor of 36, and actually 2 times 18 will give me 36. 3 plus 6 is 9, which is a multiple of 3, so I know that 3 is a factor of 36, and 3 times 12 is 36. I know that 4 is a factor of 36, and 4 times 9 is 36. And I also, I know that 5 is not a factor because 36 doesn't end in 5 or 0, but I know that 6 is a factor of 36, and in fact 6 times 6 is 36. So I can do the same thing for 20. And I know that I'm going to have to look at all of the factors or all the natural numbers as possible factors that are less than 4 or 4 or less, because the square root of 20 is actually 4.4, I think, 4 point something. So I'm going to have to try everything up to 4. So I know that 1 is a factor of 20, and 1 times 20 is 20. I know that 2 is a factor of 20, and 2 times 10 is 20. 3 is not a factor of 20, but 4 is, and 4 times 5 is 20. And that's it, because all I had to do was check up to 4. Now, what is the largest number that is in common to both 36 and 20, to the factor list of 36 and 20? Well, it's 4. So in this case, the GCF is 4. All right, if we have larger numbers, however, the listing method can be impractical. So we can also use the prime factorization of numbers to find the GCF. So what we're going to do is we're going to find the prime factorization of each number, and then we're going to multiply the smallest powers of any primes that are common to all of the numbers. So the next pair of numbers that I have here is 600 and 540. So yeah, definitely using the listing method would be very tedious here because I'd have to list all the factors of 600. I'd have to list all the factors of 540. So let's just use the prime factorization. So the first thing I'm going to do is find the prime factorization of each number. So 600 I can actually break up into 60 and 10. 60 I can break up into 6 times 10. And 10 I can break up into 2 times 5. 6 I can break up into 2 times 3. And 10 I can break up into 2 times 5. So really what I have is 2 times 2 times 2 times 3 times 5 times 5. Or 2 cubed times 3 times 5 squared. Now, 540 I can break up into 54 times 10. 54 I can break up into 9 and 6. 9 I can break up into 3 times 3, and 6 I can break up into 2 times 3. Didn't make my 3 there. And then 10 I can break up into 2 times 5. So really what I have here is 2, having some trouble with my pen today, 2 times 2 times 3 times 3 times 3 times 5, or 2 squared times 3 cubed times 5. So I have the prime factorization of my two numbers. So what I need to do is I need to list any factor that is in common to both prime factorizations. And then once I have those factors, I'm going to multiply them up to find the greatest common factor. Now what you want to do is if you have a factor, or when you have a factor that's in common, you want to choose the one with the smallest exponent. So here I have 2 cubed and I have 2 squared. So basically I want to choose for my greatest common factor, I want to choose 2 squared. Times, I have a 3 in both. The smallest 3 I have is just 3 without an exponent, so I want to choose 3. And then I have a 5 in both, and the smallest 5 I have is 5 without an exponent. So I have 2 squared times 3 times 5. And that gives me 60. So the GCF in this case is 60. All right. So what I'd like for you to do is to try the next pair of numbers. Find the GCF of 700. Actually, let me erase that 0. It wasn't very good. So find the GCF of 700 and 360. And go ahead and pause the video and try this on your own, and then continue to watch the video, and we'll see if our answers match. Okay, so I know that I'm going to use the prime factorization method. So I know that 70 times 10 is 700, so I'm going to use 70 times 10. And 70 can be broken down into 7 times 10. 7 is prime, and 10 can be broken down into 2 times 5. 10 can be broken down again into 2 times 5. So here what I have is 2 squared times 5 squared times 7. Now 360 can be broken down into 36 times 10. 36 can be broken down into 6 times 6. And 6 can be broken down into 2 times 3, and I'm going to do that twice. And then 10 can be broken down into 2 times 5. So really what I have here is 2 cubed times 3 squared times 5. Now, 2, the factor of 2, and the factor of 5 are the only two factors I have in common. So those are the only two that's going to be included in my greatest common factor. So what I'm going to do is I'm going to take 2, the smallest exponent. I have a 2 squared and a 2 cubed, so I'm going to take 2 squared, smallest exponent, and multiply that by the smallest exponent, or the 5 with the smallest exponent. So the 5 with the smallest exponent is just 5 without an exponent. So now 2 squared times 5 is 4, and 4 times 5 is 20. So the GCF of 700 and 360 is 20. The lowest common multiple, or LCM, is sometimes referred to as the least common multiple, but I grew up saying lowest common multiple, so that's probably what I'm going to say. What it is it is the smallest number that is a multiple of all the numbers in the group. And the greatest common factor and the lowest common multiple, I think, sometimes cause confusion, because even though the greatest common factor is the greatest common factor, it's often a very small number, like 4 we saw. And even though the lowest common multiple is the lowest common multiple, it's often relatively large. So it seems to be backwards, right? But again, we can find the lowest common multiple by we can list the multiples of each number, and we pick out the smallest multiple they have in common. So if you notice on your sheet, you have the first example says to find the LCM of 8 and 6. So if I have 8 and 6 and I want to find the lowest common multiple, what I'm going to do is just find the multiples of 8 and the multiples of 6, and then choose the first number in each list that is in common to both lists. So when I find the multiples of a number, I just simply start multiplying that number by natural numbers. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. And I think we can stop there. Let's see the multiples of 6 and see if we have any that are also multiples of 8. So the multiples of 6 are 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And 6 times 4 is 24. And notice, 24 is common to both lists. So the lowest common multiple is 24. So LCM in this case is 24. Now, if we have larger numbers, just as with the greatest common factor, it becomes very tedious to use the listing method to find the lowest common multiple. So we can also find the lowest common multiple using the prime factorization. So you have 600 and 540 there. This time we're going to find the lowest common multiple. So 600 and 540. We already know the prime factorization of each of these numbers, and I chose those because we already knew the prime factorization, so we don't have to find it again. For 600, if you recall, it's 2 to the third times 3 times 5 squared. And for 540, it's 2 to the second times 3 cubed times 5. Now, for the lowest common multiple, we're going to multiply together the largest powers of all primes that occur in any of the numbers. So if a factor occurs in either of the numbers, it has to be in the lowest common multiple. And we're going to choose, if a factor is in both, the one with the largest exponent. So 2 is in both, so I'm going to choose the 2 with the largest exponent. That's 2 to the third. 3 is in both, so I'm going to choose the 3 with the largest exponent. That's 3 to the third. And 5 is in both, so I'm going to choose the 5 with the largest exponent, and that's 5 squared. Now, if I had some factors in either the prime factorization of 600 or the prime factorization of 540 that were not in the other, I would have to include those as well. I just wouldn't have to choose the highest exponent because they would only be listed in one of the factorizations. So 2 to the third times 3 to the third times 5 squared, when you multiply all that up, you get 5,400, and 5,400 is the lowest common multiple. Now, pause the video and go ahead and try to find the LCM of 700 and 360, and then continue watching the video to see if our answers match. Now, you already know the prime factorization of both of these numbers because we already found the greatest common factor of those two numbers. So go ahead and try to find the lowest common multiple, and then we will compare our answers. Okay, so I hope that you worked out this problem. So let's review the prime factorizations. For 700, the prime factorization was 2 squared times 5 squared times 7. And for 360, it was 2 cubed times 3 squared times 5. Now, I have a 2 as a factor in the prime factorization of 700 and 360, so I need to choose the highest exponent, so I'm going to choose 2 to the third. I have a 5 in both, so I'm going to choose the highest 5, and that's 5 squared, so 2 to the third times 5 squared. Now those are the only two factors that I have in common, but since I have a 7 also, I need to include 7 in the lowest common multiple. And I also have a 3, so I need to include 3. And the only exponent I have on a 3 is 2, so I'm going to choose 3 squared. Notice that the only difference is that if you have a factor in both, you choose the highest exponent. But if a factor occurs in just one of the prime factorizations, it automatically, with its exponent, goes in the LCM. So when I multiply 2 to the third times 5 squared times 3 squared times 7, I get 12,600, and that is the LCM. All right. Now, if you continue reading the information sheet, it says if you know the greatest common factor of a group of numbers, you can use it to find the lowest common multiple. And if you know the lowest common multiple of a group of numbers, you can use it to find the greatest common factor. So consider the following relationship, and I will actually write this one down so we can see what's going on. So if I have the greatest common factor, the GCF of two numbers A and B, and I multiply that by the lowest common multiple of the two numbers A and B, then that's going to be equal to the product of the two numbers, A times B. So I can use that to come up with two formulas. If I need to find the greatest common factor, I'm just going to find the product of the two numbers and divide by the lowest common multiple if I know it. If I want to find the lowest common multiple, I'm just going to multiply the two numbers and divide by the greatest common factor. So let's look at an example here. It says find the greatest common factor of 24 and 88, and then use that to find the lowest common multiple. So I think 24 and 88 are small enough that we can just use the listing method to find the greatest common factor. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and 7, it will not go into 24. So here are the factors of 24. And the factors of 88 are 1 and 88, 2 and 44, right? 3 will not go into 88. 4 will, however. 4 times 22. 5 will not go into 88. 6 will not go into 88 because 3 doesn't. 7 doesn't go into 88. 8 does go into 88. So 8 times 11. 9 will not go into 88. 10 doesn't go into 88. And that's all we needed to test. So what is the greatest common factor? Well, I notice that 8 and 8 is the largest number that's in common to both of those. So the greatest common factor, or the GCF here, is 8. So to find the LCM, what I'm going to do is I'm going to take the product of 24 and 88 and divide it by 8. So the product of 24 and 88, when I multiply those together, I get 2112. And when I take 2112 and divide it by 8, I get 264. Let's try another one. This is 468 and 1848. So I need to find the greatest common factor of these two numbers and then use it to find the lowest common multiple. It's going to be very tedious to do the listing method, so I'm going to find the greatest common factor by finding the prime factorization. So I'm going to break 468 up into 2 and 234. Then I'm going to break 234 up into 2 and 117. And I'm going to break 117 up because 7 plus 1 plus 1 is 9. This is a multiple of 9. So I'm going to break it up into 9 times 13. 9 can be broken up into 3 times 3. So I have, as the prime factorization of 468, 2 squared times 3 squared times 13. So 2 squared times 3 squared times 13. Now, 1848. I can break that up into 12 because 1848 is a multiple of 3 and 4, so it's automatically a multiple of 12. So that's 12 times 154, and all I did was use a calculator to divide that. 12 can be broken up into 3 times 4, and 4 can be broken up into 2 times 2. And 154 can be broken up into 2 times 77, and 77 can be broken up into 7 times 11. So here, for this factorization, I have 2 cubed times 3 times 7 times 11. Now, the only two factors that are in common are 2 and 3. So what I'm going to do is I'm going to choose the smallest 2, that's 2 squared, and the smallest 3, that's just 3. So 2 squared times 3 is 12. So the GCF in this case is 12. Now, if I want to find the lowest common multiple, what I'm going to do is I'm going to take the product of A and B. So I'm going to take the product, and I'm going to come down here and write it. So the LCM will be equal to the product 468 times 1848 divided by the GCF, or 12. And the product of 468 and 1848 is 864,864. And if I divide that by 12, the lowest common multiple is going to be 72,072. So that's the lowest common multiple. So we have some applications of the greatest common factor. So the greatest common factor can be used to solve problems involving situations where we want to take several larger groups and represent them as collections of the same size, as smaller collections of the same size. So let's consider the following situation. It says, for an intramural bowling league, you need to divide 40 men and 24 women into all male and all female teams so that each team has the same number of people. What is the largest number of people that can be placed on a team? Now, how do we know that this is a greatest common factor problem? Well, we need teams of the same number of people, so we're dealing with groups of the same size. We start out with a larger group, 40 men and 24 women, and we're going to break those down into smaller groups of the same size. We need to find the largest number of people that can be on a team, and largest number relates to the greatest common factor. So that's how we know this is a greatest common factor problem. So I'm going to find the greatest common factor of 40 and 24. I can do the listing method here. It's very easy. So 1 and 40 are factors of 40. 2 and 20 are factors of 40. 3 will not go into 40. 4 will. 4 and 10. 5 will. 5 and 8. And 9 will not go into 40. So those are the factors of 40. And the factors of 24 are 1 and 24. 2 and 12. 3 and 8. And 4 and 6. So I notice that 8 is the largest number that's in common to both of those lists. So the GCF is 8. And the largest number of people that can be placed on a team is 8. And how many teams of all men will there be? Well, if I have 40 men and I need to place them in teams of 8, I'm going to have 40 divided by 8 or 5 teams of men. How many teams of all women? Well, if there's 24 and I'm going to put the women and I'm going to put them in teams of 8, I'm going to have 24 divided by 8 or 3 teams of women. Let's look at another example dealing with the lowest common multiple. So if you look at the information sheet, it says the lowest common multiple can be used to solve problems involving situations where we have 2 types of objects and we want to get enough of each object to get a larger group of the same size. We don't want any objects left over. So consider the situation. Now, what I'd like for you to do is pause this video, and if you have that, if you have your information sheet pulled up on a computer, go ahead and click on the video there and watch that situation. This is a situation from Father of the Bride, starring Steve Martin. And in this situation, he goes to the store and he wants to get hot dogs and hot dog buns. But he notices that hot dogs come in packages of 8 and hot dog buns come in packages of 12, right? So watch, if you would like to, watch that. It's pretty funny. Father of the Bride is a funny movie. Steve Martin is funny in it. And it's a fun little clip. So the issue here is that hot dogs come in packages of 8 and hot dog buns come in packages of 12. So we want to know what is the least amount of hot dogs in buns that George Banks, who is Steve Martin's character, can serve and not have any leftover dogs or buns. Well, this is a lowest common multiple problem, and the way we know that is because we have 2 different objects, hot dog, buns, and hot dogs. We want to find the least amount, so that's the lowest common multiple. And hot dogs in buns, I'm going to serve a hot dog in a bun, so that's a larger group. And we don't want to have any hot dogs or buns left over. So that's how I know that this is a lowest common multiple problem. So I just need to find the LCM of 8 and 12. So we can do this through listing. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. Let's look at 12. 12 times 1 is 12. 12 times 2 is 24. And we have our winner. 24 is the lowest common multiple. So, George Banks can serve 24 hot dog buns, so 24 hot dogs in buns, I mean. So 24 hot dogs in buns. And how many packages of hot dogs will he need to buy? Well, if he needs to have 24 hot dogs and they come in packages of 8, he'll need to buy 3. And how many packages of buns will he need to buy? Well, if he needs 24 and they come in packages of 12, he'll need to buy 2. So let's look at another example with the lowest common multiple. It says Finn and Jake are running around a circular track in the same direction. Finn can run completely around the track in 15 minutes. Jake takes 18 minutes. If they both started running from the same spot at the same time, how long will it take them to arrive at the same spot at the same time again while running? So they're running around a track, they run at different speeds, or they take different times to make a complete lap around the track. And how do we know this is the lowest common multiple problem? Well, we have 2 different groups. Really, we have a Jake who can run 15 minutes, run around the track in 15 minutes, or sorry, Finn that can run around the track in 15 minutes, Jake that can run around the track in 18 minutes. So those are two different sets of running times, we'll say. There are two smaller groups of minutes. We want to find a larger group of minutes. So how many minutes until they're both in the same spot again? And the first time they meet, they're in a common place, and it's the it's the first time, so it's the least time. Now, if they continue running, they will meet again and again and again, but the first time they meet will be after the smallest amount of minutes. So we need to find the lowest common multiple of 15 and 18, and I still think we can list. So 15, 30, 45, I'm just multiplying 15 by 1, 2, 3, and so on. 60, 75, 90. Okay, let's see 18. 18 times 1 is 18. 18 times 2 is 36. 18 times 3 is 54. 18 times 4 is 72. And 18 times 5 is 90. And look, 90 and 90 are the same. So after 90 minutes, they will be at the same spot again. All right. Well, that covers the information sheet. I hope that this video was helpful, and we'll try again next week. Now, next week, we will be on Monday meeting through Blackboard Collaborate again. We'll try to talk about sequences, and then on Wednesday, I'll be in Lee County, but I will be broadcasting to everyone, hopefully. And we'll actually, on Wednesday, we will review for a test, and then I would like for you all to take your test either on Thursday or Friday. If we end up having school, we've been having some inclement weather. But if not, we can work on the test next week as well. Like I said, I hope this helps, and I hope y'all have a good weekend, and I will see you soon.